and then separately applying sorting, we can do something better. What we can do is, we know that whenever we square a number, it will be always a positive number. Can I say that? Right? At any point of time when you actually square a number, right, it is always and always going to be a positive number. Can I say that? Okay. So let's say I create an array, initially empty. Okay. Initially I create an empty array of length n. So we create an empty array of the same length as of this particular array. Okay. Cool. And then let's start actually talking about it. So can I say that the two extreme ends of the given array, if they are squared up, if you square them up, then they are going to give me the largest and the second largest element altogether. Can I say that? Because one end is extreme negative, one end is extreme positive. When these two elements will be squared up, one of them will be the largest element, one of them will be the second largest element. Can I say that? Right? So because we have positive and negative numbers, the first and last element, when squared up, gives the candidate for the largest element. Can I say that? We can say, let's say I'll add one more element. Okay, I'll add one more element. Let's say 5. Okay, cool. So what we can say is that the elements at the two extreme ends are going to decide who will be the largest element in this resultant array. This resultant array is the array of squares. Can I say that? Right? Now, why is that? Just think about it. This given array is arranged in ascending order, right? It is already given in the question. Let's see. It's already arranged in ascending order, right? If it is arranged in ascending order, can I say the last number is going to be the largest number, right? And the square of the largest number can be one of the largest numbers in the final array. Think about it now. 5 into 5 is 25, right? This will be the largest in the resultant array. Apart from that, let's say you have a -7 here. Now, -7 is the smallest number. Can I say that? -7 is the smallest number here. But because it is a negative number, and the square of a negative number is always positive, the square of the smallest negative number is also a possible candidate to become the largest number of the squares. Can I say that? So 5 into 5, 25, or -7 into -7, 49. One of these is going to be the largest element. Can I say that? Right? Why? Because this is the biggest element already. So the square of the biggest element will be having a good chance to become the biggest element. But this can be the smallest negative as well. Maybe there is no negative part. Maybe there is no negative part. But if there is a negative part, then the smallest negative element, when squared up, can give us probably the largest positive number. Can I say that? And this is the logic that we are going to play on. Is this point making sense? Sahil Kumar, did you get this point? Okay, cool. Cool. Let me talk about that. Now let's say, guys, instead of -7, let's say we were just having -4. Okay. Now if you're just having -4, then what is the square of -4? 16. Can I say 25 and 16? This is still one of those elements is going to be the largest element. This time 16 won't be there, but at least 16 is larger than a lot of other squares. So can I say these two are the best candidates to choose from? That who will become the largest element. If they were -7, then this would have contributed to the largest element. But here we have -4, so 5 will contribute to the largest element. So what is the intuition? The intuition is that the elements that are far apart are capable of contributing to the largest element. If that is the case, how about if I keep two pointers, one as left, one as right, at the two extreme ends, and I compare, is the square of right greater than the square of left? Is the square of right greater than the square of left? Yes, it is. So what I'll do is I'll keep a variable I on this array, because we're going to start from the last, because we'll get the largest element first. We'll check, is 25 greater than 16? Yes. So what I'll do, I'll put a value 25 here. I will do I minus minus, because now I want this particular element, and because right has been used, I'll do right minus minus, and we are here. And we can say this much part is already done. Now the same theory we apply here. Is 4 into 4 16 greater than -4 into -4 16? They both are equal, right? If both of them are equal, anyone can go here. So let's say this one is going to go. We'll put a value 16 here. We will do left plus plus. We'll do I minus minus, right? And now you can say this much part is done, and this much part of the array is done. Can I say? Now in this remaining array, you have these many elements to fill. Now, -3 into -3 is 9. 4 into 4 is 16. Which one is bigger? 16 is bigger, right? Which one is bigger? 16 is bigger. So we will put this 4 into 4, 16 here. We'll move right here. We will move I here. And can you see? Now, these many elements are done. We are left with these elements. Can I say that? So at any point of time, what I'm trying to say is that if you check the extreme two ends of the given array, right, then one of these elements is going to be the biggest element. If we see the extreme two ends, then square of one of them is the biggest element. Right? Same thing will happen here. For example, if you see -4 and 5, square of 5 was 25. So this becomes the biggest element. Instead of -4, if it was -7, then -7 into -7 would have been 49. This would have been 25. This time 49 would have contributed. One of the extreme ends is going to contribute to the largest element. If you carefully see now, this much part is done. 3 elements are already in. This is the remaining array, and this is the remaining array. Now again, the same thing will happen for this particular part. Here, the two extreme ends, 3 and -3, are going to decide who will come here. Now 3 into 3 is 9. -3 into -3 is also 9. Anyone can come up. So let's say I'll put this -3 into -3, 9 here, and I'll move left here. I'll move I here. Now again, we have two extreme ends. -2 into -2 is 4. 3 into 3 is 9. This 9 is bigger. So this 3 is going to contribute here. 9 comes up, and we do right minus minus, and so on. So what we are going to do is, we are going to say, let's say left is equals to 0. 1 second. Left is equals to 0. right is equals to n minus 1. Can I say we are going to put both of the elements at the two extreme ends, and we are going to take a variable I is equals to n minus 1 also, and we'll say for, or let's keep it inside the variable only. I is equals to n minus 1, I greater than equal to 0, I minus minus. This variable I is going to iterate on my resultant array. Okay, we will say that if nums of left square is less than nums of right square, right? If the value at the left, the square of the value at the left is lesser than the square at the value of the right, then what we are going to pick? We are going to pick the value at the right, right? So we'll say result of I is equals to nums at right square, and then we do right minus minus. Else we will say nums at I is equals to, sorry, result at I is equals to nums at left square, and we do left plus plus, right? We do not need to separately do I minus minus, because in one iteration I minus minus will already happen. Can I say that? Right? So let's see if this algorithm will work for us or not, right? Let's see if this algorithm will work for us or not. So let's say we take something like minus 3, minus 2, 0, 1, 2. Okay, let's say this is the given array. Okay, so initially you put left on 0, right on minus 1, n minus 1. So left is here, right is here. You have a resultant array of the same size. You have a resultant array of the same size, and I starts from n minus 1. So I is pointing here. Can I say that? Okay, and now we will check if the element at left square is less than the square of the right element. That means if 3 minus 3 into minus 3 9, is it less than 2 into 2 4? Is 9 less than 4? No. That means you go to else, and here what do? You say result at I is equals to left square. So what is left square? 3 into 3 9. You do left plus plus, right? So you do left plus plus, and that's it. And that's it. For next iteration, you do I minus minus. So I minus minus, right? Then again, you are going to compare, is left square less than right square? So is 4 less than 4? No. Both are equal, right? So any one of them can go. So we'll go to else, and we'll put this one. This minus 2 is going to contribute to 4. We do left plus plus and I minus minus. Same thing again. Same thing again. Is left square 0 into 0 is 0, less than right square 2 into 2 is 4. Is 0 less than 4? Yes. This statement is true. So we are going to put right square. So this 2 is going to contribute to a 4 here. Then we do right minus minus. We do right minus minus. And now we are here. Then we do I minus minus. And then same thing will work. You compare 0 into 0 is 0, 1 into 1 is 1, 0 is less than 1. This 1 will contribute here. This 0 will contribute here. At last, you'll be having all of the square values in increasing order. Right? This is going to do the solution for us. Right? Here we have to take the extra array, otherwise manipulating things in the same array can become very difficult, because you are going to keep on taking the values, and you might have to shift a lot of values. That's why we are going to take a new array altogether. But this time the number of instructions are going to be very less. Okay, that was our main agenda. So if you try to implement it, whatever I wrote, same thing I'll do. So let n is equals to nums dot length. Let result is equals to a new array of size n. Okay, a new array of size n. We'll say let left is equals to 0, right is equals to n minus 1, and we say for let I equals to n minus 1, I greater than equal to 0, I minus minus. Okay, and then we compare if nums of left square is less than nums of right square. If that's the case, then result of I is equals to nums of right square and right minus minus. Else, result of I is equals to nums of left square and left plus plus. At last, we are going to return result. If you run the code, submit, and you can see things have accepted. So that's how you will actually solve this particular question. Okay, now let's start taking questions. Okay, let's start taking